Thanks, Jack. So I'm going to ask everybody a question. Okay. When you think of what water tastes like, what do you expect your water to taste like when you drink it? Okay. So I heard clean and no taste. What was that? And some hope that it would taste like vodka, but it wouldn't necessarily. Yeah. So I'm going to just summarize some of what I'm going to cover today, just so you know what kind of take-home messages I'm trying to provide. If you sit down and you taste, you need to not eat for 30 minutes or smoke or drink anything other than water. But if you sit down and you buy 4 different bottled waters from the grocery store, I am pretty 95% sure when you taste those 4 different bottled waters, they're going to each taste a little different to you. And the reason for that is our nose is one of the most powerful analytical instruments on Earth. We can detect constituents in water at low nanogram per liter or part per trillion levels. And these constituents that are in water, some are naturally occurring, some of them are degradation products from algae, others might be industrial inputs, but they're not a public health concern. They're not at levels that are going to cause you to get sick, but they are a concern for consumers because you expect your water to have no taste. You expect it to be clear. And if you detect a taste to your water, at a minimum, it's going to have aesthetically be displeasing to you as a customer or consumer, but it can also create some concern if you're not aware of where that taste is coming from as to whether or not your water is safe to drink. So the last point I'm going to make before moving into the slides are that these constituents that can impart a slight taste and odor to water are found in source waters. They can occur at the treatment plant. They can occur through the distribution system, or they can occur through household devices or premise plumbing. Okay, so when I started in consulting, the first fellow I worked with was Dr. Mike Mcguire, and I wanted to acknowledge him in particular. He, along with a few others, was really instrumental in developing methods, new methods to detect tastes and odors in water. And a lot of the slides that I'm presenting today are derived from some materials that he has produced throughout the years. He also he and others engaged with the American Water Works Association to develop a manual and video to screen and train panelists for the flavor profile analysis. And there's some really good materials in that. The videos alone, even if you don't want to be a flavor profile analyst, they're good background on the tastes and odors that can be detected in water. So an overview of what I'll be presenting. I'm going to provide some background materials on taste and odors in drinking water. Then I'll go through the taste and odor sources and control strategies depending on whether or not you're at the source, within the water treatment plant, in the distribution system, or at the household. And then I have a few slides on some of the sensory and analytical methods to detect taste and odor causing constituents in water, and then summarize. Jack, you're going to have to tell me when I need to end because I'm not sure when I started. Okay. So the EPA has established primary drinking water standards for a number of constituents in water, and those primary drinking water standards are set to protect public health so that we're not exposed to microbial or chemical contaminants at levels that would cause us harm. Okay, so recognizing that, let's put that down, recognizing that there are also things in water that do not cause us harm but can impart aesthetic taste issues or color issues to water, EPA has also promulgated secondary maximum contaminant levels or standards for some of the constituents that are shown on this slide and the next. And TCQ has also established some of their own secondary MCLs. And these SMCLs, they're non-enforceable. So if you're a public water utility and you detect iron at a concentration above 0.3 milligram per liter in your water, EPA is not going to go give you a notice of violation and you go to enforcement. It's not an enforceable standard, but it's set as a guideline, recognizing that if you do have iron in your water above 0.3 milligram per liter, you might have some issues at the tap with coloration, a metallic taste to the water. So then looking at the next slide, just kind of a snapshot of some of the other constituents with secondary standards. Total dissolved solids imparts a salty taste to water above, EPA set an SMCL of 500 milligrams per liter. TCQ has established a standard of 1,000 milligrams per liter as a guideline. Okay, so in the 1990s, a fellow by the name of Dr. Mel Suffet, who's a professor at UCLA, he and Mike Mcguire and a few others were instrumental in developing this taste and odor wheel that classifies the tastes and odors that could be detected in drinking water. This one is specific to drinking water. Another one has been developed for wastewater. So I'm going to walk you through it. The blue portion of the pie chart or circle illustrates the 4 tastes that we can detect. And those tastes are it's the same across anything, water, wine. They're tied to different parts of our tongue, and you can taste a sweet taste, a salty taste, bitter, like coffee tastes a little bitter, sour. You can also have a mouthfeel. And that's, when you drink wine, a lot of this kind of is analogous to wine tasting. When you drink wine, you might say that wine is dry. So you can actually have a feeling on your tongue on whether or not something tastes slimy or dry, and that's captured in this wheel. There are 8 categories of odors that were identified for water, drinking water, and those are represented in the green portions of the wheel. And just a couple things about the green odors portion of the wheel. We can, like I mentioned, we can detect things in water. Our olfactory nerve is very sensitive. It's part of the reason why the wine industry probably makes so much money, is because we can detect those subtle differences in wine, and that's tied to the power of our olfactory nerve that can detect things at low nanogram per liter levels or part per trillion levels. And so we might detect a chemical flavor to water, and that can be tied to different constituents that might be in the water, like MTBE would be an example of that. MTBE has a secondary MCL in a few states, recognizing that it does impart a taste or flavor to water. An example for chlorinous is pretty commonly attributed characteristic to water. It's tied to the application of chlorine or chloramines. So moving on, in 1990 there was a utility survey on the types of odor problems in drinking water, and this slide represents the results from that survey, where the number one odor problem was customer complaints or concerns over chlorinous taste, and that reflects the use of chlorine, which is protective of public health. There's a good reason why we add chlorine, but it does impart a taste, a flavor to the water. Earthy, which is tied to, I'll talk a little bit more about that, is tied to metabolites of blue-green algae, and then you can read through some of the others. So there are different odors odor characteristics to water, they're tied to very low levels of different things that are ubiquitous in the water that we drink. And you get water from a lake, it has iron in it, it has minerals, and those different characteristics of water can impart different tastes. So where do those taste and odor problems come from? They can come from the source, they can come from the treatment plant, the distribution system, or the household. And I'll walk through each one of those sources. In source water, you can have things that are naturally occurring, like chloride, sulfate, total dissolved solids that impart a salty taste to the water. You can also have metabolites from blue-green algae, actinomycetes also produce these metabolites, and they create kind of an earthy or beet taste, musty taste to the water, flavor. Industrial discharges, the really low levels of constituents that may or may not be regulated, and if they are regulated, they're below the drinking water standards. They're not a public health concern, but they can cause, like a phenol, chlorophenol can cause a medicinal flavor to the water. Agricultural discharges, bolero has been tied to a bitter taste to water. So just, I have a couple slides on geosmin and MIB, because these metabolites from blue-green algae are one of the more commonly detected taste and odor issues in water. Geosmin it occurs at low, 0 to 200 nanogram per liter. It spikes up in the summer when the algae starts to bloom. Customer complaints can occur at above 10 nanogram per liter. Some people are more sensitive to tastes and odors than others. And so a sensitive population might detect geosmin in their water at 5 nanogram per liter. The odor that geosmin produces is kind of interesting. If you ever engaged in a panel, you can actually tell the difference between geosmin and MIB. Geosmin has a beet taste to it, so it has kind of a little, that's a distinction for geosmin. MIB is also a metabolite from different algae. It can be detected at low nanogram per liter methods through different analytical techniques. Our nose can detect it also at those levels. You can start to see customer complaints when MIB gets above 10 nanogram per liter. And it has more of an earthy, peaty flavor to it. Other common surface water odor qualities, you have grassy green vegetation. I have some notes on this, let me do this. There's green algae and plants produce something called cis-hexanol, and at 50 parts per billion, you can detect kind of a grassy flavor into your water. So these odors, I mean, they sound kind of funny, but there are actually constituents that can tie to why you're detecting them in the water. But these constituents are really low levels, and they're not a health concern. Different algae produce nonodienol, which creates a cucumber taste, and which would be described as like a vegetable within the vegetable category. So, I mean, clearly there are a lot of different, from the work that Mel Suffett did and others, there are a lot of different odors that you can detect in your drinking water, and that's why we get customer complaints, and there might be something that's at really low levels that's causing that water to have just a little bit different profile or taste to the customer. Some of the source water control strategies, and if you're using groundwater as an example with high total dissolved solids concentration, tastes really salty. If your wells have 1,200 milligram per liter TDS, one strategy is, rather than put in a really expensive RO system, if you have another well, surface water supply with lower TDS, you can blend to deal with the TDS. For lakes, when you're dealing with iron or manganese or a seasonal MIB and geosmin event, you can have variable intake depths, which is shown in that, so it's shown in this image. You can also aerate, it's called hypolimnetic aeration, where you're aerating at the depth to where you're starting to get anoxic conditions and producing some the anoxic bacteria and organisms are producing some, converting sulfate to sulfide, doing some things that make the water have more of a septic characteristic. You can also do mixing to destratify the reservoir, which is shown down here. And then if you have a blue-green algae problem, you can add chemicals like potassium permanganate or copper sulfate. So now we get into the water treatment plant. I don't know how I'm doing on time, but there are sources of taste and odor at the water treatment plant. Those can include the chemicals that we add, chlorine. This little table at the bottom shows the odor thresholds for different chlorine compounds. If you add chlorine as hypochlorous acid or hypochlorite, I mean, it's essentially the top two are if you add chlorine, there's a odor and flavor threshold levels of around 0.3 milligram per liter. Chloramines have different odor threshold levels. So depending on what disinfectant you use, you might get different concerns from your customers on the chlorinous taste of the water. We were actually working with a utility in Central Texas, and they had a MIB angiosmin event, and it was actually not from the source water. It was because their residuals basins were just sitting and baking in the sun, and they had algae growing, and then they started to detect an MIB angiosmin event. They added chlorine, they lysed all the cells, and so I have 15 minutes? Okay. And as soon as the cells were lysed, all the MIB angiosmin went, and they went to their customer city, and they got calls out the roof. So you can also get problems in the water treatment plant, but primarily treatment is the treatment plant is where you've solved the problem. So you ideally, so you can reduce taste and odors through oxidation. If you know you have a summertime MIB angiosmin event, you can add powder activated carbon, you can add permanganate. There are a lot of things we do at the treatment plant that can help address some of these issues. So this next slide is kind of illustrates where the water quality, when you get the water at the source, it has a certain characteristic and certain quality, and it goes through your raw water transmission main into the treatment plant, and then you treat the water, and the water quality improves. It goes way up. And the take-home message from this slide is that your best water quality is at the entry point to the distribution system. It's after the water's gone through treatment, you've met all the primary drinking water standards, and then it goes through the distribution system. And I'll start talking about the distribution system in the household, but all sorts of things can happen in the distribution system that can start to degrade the quality of water. And that's depicted in this slow decline in the water quality through the distribution system. Okay, so I'm going to go through some things that can happen in the distribution system. You have biofilms along the pipes. Chloramines or chlorine are added and maintained as a disinfectant through the distribution system that helps control some of the biofilms, but you can still have biofilms growing in the pipes. And the organisms in the biofilms can produce septic or swampy odors. This next slide illustrates that a little bit further, where you can have, like for an iron pipe, you can have iron tubercles. I'm not pronouncing that word right, but you can have the corrosion profile within the pipe, and as the water goes through, if some of those corrosion deposits are released, within the aerobic layer, you can have some microbial activity that's producing some microbial byproducts that impart taste and odors, and also in the anaerobic layer, you may be more likely to get something like a rotten egg type taste, septic. So the release of these corrosion layers can also impart taste and odors to the water. In the distribution system, if you particularly when you have a common inlet and outlet, the water can stagnate if you don't have good turnover with the water, and then what happens is your chloramine residual can decay. You don't have that microbial barrier anymore. You get bacteria grow, septic conditions can occur, and then odors are produced. And then when the tank's level drops, you get a slug of water that goes out into the further into the distribution system to the household tap, and you get complaints. So now I'm going to go through a couple of case studies. When you put in new mains, the materials are different piping materials. They're made out of things that are man-made, and we use chemicals to make these materials, and there can be, it's not a public health concern, but there can be, because they're going to be NSF 60 certified for use in drinking water, but there are things that can impart a slight taste or odor to the water. And so there was a case of where some customer complaints were occurring sporadically after new main installations, and then the odor disappeared by the time a response was made to the customer, but a flavor profile analysis panel went out, took a sample, and aldehydes were actually detected with the FPA panel detected a wet paper rancid odor. They went back and did send a sample based on that response, sent a sample to the lab and detected the aldehydes. Another case of a new plastic pipe, the Hdpe pipe can have a burnt plastic odor. So again, the materials we use can also release low concentrations of things that are not a public health concern, but can impart a taste and odor to water. When you blend in the distribution system, this is kind of interesting because we are really sensitive. Our tongues can taste 4 different tastes. We have this really powerful olfactory nerve. And so when you change your water source, what you're drinking, it may, you may be used to drinking 900 milligram per liter total dissolved solids out in El Paso, and you get used to it, and you come to somewhere else and the TDS is lower, and doesn't taste like your water. And by someone else's standard, that might be a preferable water source if it doesn't have as high a TDS level. But you get used to what you're drinking, and when you get a change in the particular flavor characteristic of your water, you can have a concern. And so particularly for utilities that are on groundwater and then they switch to surface water, groundwater uses chlorine, surface water they're using chloramines. They get a difference in the chlorinous taste of the water. Chloramines, I think, have more of like a swimming pool descriptor of the taste and odor. So blending water can cause some customer complaints and concerns because the change in the flavor characteristics of their water. Solutions to distribution system problems: flushing, kind of preventing those water age issues, controlling blending, reservoir maintenance, making sure you don't have biofilm corrosion build up within the reservoirs, increased hydraulic turnover in tanks so you maintain fresh water, chlorine boosting, so you do keep a chlorine or chloramine residual in your distribution system. And new mains is a solution, but it also has to come with awareness that you can put in a new main. There are these case studies where something releases and some sensitive population of the customers can detect a slight taste and odor issue. So now we move on to household. So this slide just has a long laundry list of some of the common tastes and odors from household plumbing, and it's just illustrates you can get all the same tastes and odors of the household as you can at the source and in the distribution system. So where are those tastes and odors coming? If say you get great water quality all the way through the distribution system and to your house, and then what can happen to the house to degrade the flavor profile of your water? New plumbing materials at your home, corrosion in your premise plumbing, cross connections, permeation of services, and I'll talk a little bit about a case study along those lines. Hot water systems, I think it's people are pretty most aware of the issue that can happen in hot water heaters where you get sulfide production either from reaction with the anode in the hot water heater or anaerobic bacteria that grow in that warm environment. Also point of use devices if they're not maintained properly. So a couple case studies. There was an oily odor detected. It was mostly from the cold water. Samples were collected. The chlorine was low, turbidity was high. And what happened was they had a home radiator, and when it was installed, there was not a check valve, and that heater water was backflowing into the tap. And so that was causing an issue. Septic odor found only at the sink. The odor was actually coming from the drain. It wasn't the water. So then in a case like that, you can pour some bleach down the drain and reduce the odor from the drain. Sulfurous odor was found only at the kitchen sink, and what happened there is that there was a point of use device that hadn't been maintained. So this is kind of interesting. There was another case study of defined as the case of the persistent customer, and there was an off taste that sampling couldn't confirm the problem. Water quality samples were collected. The water quality was normal. An FPA, I'll talk a little bit about what an FPA is, but a flavor profile analysis panel came to the house. They tested the water, and they came to the house because when you take a sample, I mean, a lot of these, you smell them because they're volatile, and so if you take a sample and move it to a lab, it may not be there anymore. So the FPA panel actually went to the home, and what happened is when they first tasted the water, they didn't notice anything, but as they tasted it more and more, they started to get an astringent drying sensation, and that was actually tied to zinc and copper leaching from the household plumbing. And what can happen is I'm not going to pretend to know what the trigeminal sense is, but you can accumulate tastes. And so initially you don't detect it, but over time it accumulates and you begin to get that sensation. So solutions to premise plumbing and household problems, flushing taps upon return from a vacation. It's just like a tank in a distribution system. The water sits there for a long time, and it gets old, the chlorine residual degrades, and the water quality goes down. So when you go for a month vacation or week, however long, come home, flush your taps. Maintain point-of-use treatment systems according to manufacturer specs. Maintain the hot water heaters. When there is that sulfide taste, there are a couple things that can be done. And you can, I think for those of you in the crowd that are with public water utilities, customers can request lab tests, and those can, in an ideal scenario, provide some reassurance that the water is safe to drink. So some of the complementary lab tests for household plumbing cases, chlorine, temperature, turbidity. I think I only have 5 minutes, so I'm going to go through the sensory and analytical methods kind of quickly. Basically, if you do a flavor profile analysis or total odor number, some of these odor sensory techniques can help you hone in on what you would want to send to an analytical lab. Contract analytical labs can be, some of these methods can be pretty expensive, so you don't want to go test for everything. The threshold odor number, I think people are more familiar with, as a measure of persistence of an odor upon dilution. The flavor profile method, or using an FPA panel, there's some advantages to that. You can actually hone in on a specific odor, and it can derive an actual intensity level for that odor. It's not just one person, like the threshold odor number, you send it to a lab, it's typically one person. A flavor profile analysis is a panel, so you get a consensus of what that taste is or odor that you're perceiving in the water. Consumer panels can also be helpful. So I'm not going to go through the FPA. Folks are welcome to contact me for more information on it, but we've trained utilities to use it. It can be a really powerful tool to have early warning for an event, or be able to get a better sense of what sort of flavors and odors are in the water. So in summary, I'm going to close with some results again from that 1990 utility survey on taste and odor causes. That in order of importance, there was detection back to the distribution system, disinfection processes causing taste and odor, algal blooms, reservoir turnover, decaying vegetation, bacterial growth that could have been in the distribution system, maybe in the tanks, high mineral content, so if you have high TDS, synthetic organic chemicals. I mean, sometimes it is MTB in your groundwater, and it has a slight sweet smell to it, or industrial waste. And then focusing on the distribution system, The survey identified chlorine residual, household building plumbing, corrosion-related products, plastic pipe, and storage facility coatings as the sources of taste and odor issues. So in summary, consumers perceive risk when an off flavor is present. Our noses are very sensitive. The flavor wheel organizes tastes and odors, and water can be a tool to kind of get a sense of the types of odors that may be perceived. The best water quality is at the entry point to the distribution system, and there is that possibility of water quality degrading through the pipes. But taste and odor issues can arise at the source, at the treatment plant, in the distribution system, or the household, and the control measures are going to be highly dependent on what's causing the taste and odor and where it's coming from.